Now come to the question 4. This is very good question. There's a three spring attached to each other with angle theta, and another one with them is horizontally. Now you are given a small horizontal displacement along x-axis, I mean horizontally. Now what is the angular frequency of the small oscillation of mass m? To solve this, you need to find out what is the displacement along this two spring. That means at first horizontal displacement is x, and the displacement along this direction is x into root 3 by 2. This is the displacement among the A springs. Now the resultant force that is working along x direction, I mean x-axis, due to this spring is this. The angle between this is the angle. This is now along FA. This is the force FA. This is FA. Resultant force will be along this direction. So in the direction, restoring force, that means 3 by 2 kx. So the equivalent spring constant of these two spring, which is making angle pi by 3 with this vertical axis. So you find out the equivalent spring constant 3 by 2 Ka. Now this two spring is in series. So you find out the equivalent spring constant. That means find out this amount, and the angular frequency is just this. So option A will be the answer. Consider an object falling in air. In addition to gravity, it experiences an air resistance force R, given by R is equal to B into V. That means linearly proportional to velocity, where V is the speed and B is a constant. If the object is dropped from rest, V is equal to 0 at t is equal to 0. The distance traversed by the object at t is equal to m by b is. This is also easy. This is just a differential equation. You need to solve it. This is very much easy. You just use the boundary condition. You can see it here. Then from the expression of V, you just derive the relation between x and t, and then putting out the boundary condition, you can find out the constant, integration constant, which is equal to minus m square g by b square, and then from there you just find out the displacement of the particle or the distance traversed by the particle or object. Now come to question 6. The frictionless disc of mass m is balanced at rest on the edges of two platforms at points A and B that are equal height as shown below. The angle made by the line joining the center to point A with vertical is pi by 3. What is the magnitude of force exerted by point A on the disc? You just need to calculate, draw the free body diagram. You just calculate resultant force. You just need to calculate find out the normal force which is acting to the disc by point A. This is easy. This is this force along this is n normal force, and because they both are in the same height, so equal normal force will be acting towards the BC, and then you just find out the resultant force, which is n is equal to mg. That means the force magnitude of the force exerted by the point A on the disc is equal to mg. This is a trick question, and this is a very popular one also. This is just a half oscillator. As you know that the odd ones will be the wave function will be present in this harmonic oscillator. That means pretty much sure that the energy eigenvalue should be this 2n plus 3 into half h cut omega, odd ones only. So the ground distance should be 3 by 2 h cut omega. Omega is equal to root over k by m. You can put that there and find the answer easily. Now question number 8. There is given an unnormalized eigenfunction of one-dimensional simple quantum harmonic oscillator. So you can check this harmonic oscillator wave function. This means it is a cubic equation actually, 2s cube minus 3x. That means that this wave function has 3 nodes. So adjacent wave function should be or closest wave function should be psi, which we should have node 2 nodes and 4 nodes. That means the wave function which has 2 nodes should have quadratic equation, and the wave function which has 4 nodes should have the 4th power equation. That means option A. This, you can see that 2s square minus 1 is actually quadratic equation, and the 4x to the power 4 is a 4th power equation. That this should be the answer. This should be the closest to energy psi. Actually, the energy state of two level and second level and the 4th level. Now question number 9. This is also easy. You are given a wave function. You just need to find out angular quantum number L and the expectation value of course L square and Lz. So this is quite easy. You just need to convert it into polar coordinates. That means z is equal to r cos theta, and you know that cos theta is just represent the spherical harmonics, that is y10. That means this is L and this is M. So L is so the value of L is equal to 1, and the value of L square is equal to L into L plus 1. That is 2 h cut square, and Lz is 0 because M is 0. A thin spherical shell of radius r has a constant surface density sigma. This shell is cut symmetrically into 2 pieces. What is the electrostatic force between the 2 halves? For this, you just need to find out the force acting on, or the electric field acting on, force per unit area acting on the small elementary area ds, which is located at point P. So this is E1P is actually the force electric field due to the at this point, and E2P is the electric field due to the rest of the charge at this point. So this must be 0. From this you can calculate E2P is equal to sigma square by 2 epsilon naught. Okay, so now you just need to calculate the force. The force is that F is equal to dF sin theta sin phi. You just need to do the derivative. You can find out this equation. This is just a component. This force is a component. Now question number 11. Consider a system of 3 electric charge which is minus q placed at the point 0, 0, d, and the charge plus alpha q which is placed at the origin, and the charge minus beta q placed at the origin at the point 0, 0, minus d. This is the figure, and they said that monopole and dipole terms vanishes. Alpha and beta should be the value should be such that the monopole and dipole terms vanishes in the multiple expansion of the electrostatic potential. So what is the quadrupole term of the potential at a point x, y, 0? It means z is equal to 0. So for this you just need to find out at first what is the alpha and beta. So to find out alpha, you just need to they said that monopole and dipole terms vanishes. So summation of q is 0, and summation of dipole term q and x is 0. This is the, and if from that 2 equation solving you can get the relation alpha is equal to beta plus 1 and alpha beta is equal to 1. So and then alpha is equal to 2. So now your charge distribution is looks like that: minus q plus 2q and minus q. Okay. Now the quadrupole term is this. This is the this is the expression given by the quadrupole term. Okay. So now this is the position for minus q charge, and this is position for minus 2q charge, plus 2q charge, and this is position for minus q charge. As you can see, now we need to calculate one by one. At first, q11. Okay, so you put sorry, here to be ij actually, should be ij. Then you got the summation for no. Now the first calculate q11 terms. You can see pretty much simple this. You put I and j is equal to 1 1, and then this term is exactly sk squared and rk squared. Okay. Now simplifying it, we get this, and then one by one putting all the coordinates here with the corresponding charges, we get the q11 is 2qd square, and same as q22, this is q2qd square. Now the cross term, the all there is should be 0, but q33 terms, we should be for the symmetry of charge distribution, there should be minus 2 into q1 or q2 value. That means minus 4q d square. This is q33 term. Because you can solve it extensively, but you can also use it the trick, because the charge distribution is symmetric here, so you can calculate q33 is because is equal to minus 2q11. Putting all the value in the potential term, that means given by this expression. Now calculating all this, writing all the components q11, q2 to q33, and putting all that, and we get this expression at last. Now as it said 3z is z is equal to 0, so we put z is equal to 0, so we get this expression, which is this. See again. And now question 12. A infinite fluid of density rho, there is two spherical gas bubbles of radius r1 and r2 respectively. The gas density rho g is less than rho. The center of the bubbles are separated by a distance r, much greater than r1 and r2. If the space has no other forces than gravity, the bubble will. Of course, the bubble will move towards each other because they act at gravitational force. But what is the force? The expression of the force, we need to calculate this. So actually this is a rough diagram. This is two bubbles. What is the density of the gas inside the bubble is rho g, and the infinite fluid whose density is rho. So now m is this apparent weight, actually 4 by 3 pi r1 cube rho minus rho g, and then f is equal to just gm 1 m2 by r square. So because r much greater than r1 r2, so we can consider those bubbles as a point particles of mass m1 and m2. So just putting those formula there, we get the answer this. So there should be r square. Okay. Now question number 13. A mass of m kg of water at temperature Ta is isobarically and adiabatically mixed with an equal mass of water at temperature Tb. The specific heat of water at constant pressure is Cp. What is the entropy change del S of the system? This is easy question though. You just need to find the final temperature of the system, that is using the rules of calorimetry. That means T minus Ta is equal to Tb minus Ta. One should be decreasing the temperature and one should be increasing. So the final temperature should be Ta plus Tb divided by 2, because those are the equal of mass. And then you just calculate the del S. This is simple formula. Ta to T integration Ta to T to Ta to T and Tb to T. Okay. This is for A, this is for A, and this is for B. And the resultant force is this. Resultant entropy change. Now, a string has 8 beats in a row with n identical red beats and 8 minus n identical blue beats. when one of the red bits is replaced by blue one, the entropy of the given system changes from S to S plus KB ln 2. All configuration of the bits are equally probable. What is the value of n? For this problem, you just need to calculate the microstate for both two cases. Then you just put in the condition and find the value of n. Now for the first case, n bits can be selected from n 8 bits. The number of microstates for first case is 8cn, and for second case, because the one is substituted by the blue one, so there should be 8cn minus 1. Now we just put the condition here. Okay, second case minus the first case microstate, entropy, and it gives this 2. So solving this, you just need to factorize the whole thing. This is the, you can see it. I factorize all the components, and then we get this equation, n is equal to 6. Okay. An ideal gas on the pressure volume diagram can be taken from point K to point N along 3 different paths as shown and below: K2L to N and K to N and K to M into N. Okay. Which of the following options is a true statement? Of course, because change in internal energy is the same along each path, because internal energy is state function, so it doesn't depend on path. So option A will be correct. This is pretty simple actually. Question number 16. This is very good problem actually. You need to analyze all the data given here. A technician receives an electronic instrument on which the following circuit diagram is drawn. Based on the shown timing diagram, binary values at pins 1, 2, 3, 4, 5 as a function of time measured by the technician. Identify this fault in the instrument. Okay, you are given all the those components here, the timing diagram and the electronic circuit diagram. At first you calculate the Y output, simplify the logic gate, and then you just put all the information there to satisfy the equation or not, which you obtain by solving the logic gates, simple expression. So far, for first we just assume that this is OR gate is right, so we just get the components from the diagram, timing diagram. It is A is 0 and B is 0. Then Y, we simplify it. At first we simplify the Y output, write as a what is the expression of it. We find out the A and B bar. Okay, so we find out that the 0 0 Y will give 0, but the 5 diagram, which is the output diagram, it gives 1. That means it's not mismatched. Okay, so we just again we checking the option, we substitute with AND logic gate, and then we perfectly see that when there's 0 0, and then again we just simplify the expression for Y output, which is A plus B bar. We get that 0 0 when we supply the input 0 0, we get output Y is equal to 1, which is also confirmed by the diagram, which by 5, which is also 1. So that means option A will be the correct answer. That means an AND gate is used where an OR gate should have been used. The minimum number of 2 input NAND gates required to obtain the output A bar B plus C bar from 3 inputs A, B, and C. Okay, so let's draw the diagram. This should be the 3 NAND gate using, we will get the Y output. This is A, this is NAND gate, we will get A bar, and then B, we get this A bar B of bar of A, and then we get put C into this, and again NAND gate, we will get this simplification, we will get this answer. So at least 3 NAND gates is enough, I think, to get this expression or output. Students measure the radioactive decay of a material with a half-life of 13,000 years with Geiger counter. In the laboratory notebook, the students record the following number of decays every 10 seconds. Okay, there is 15 counts, and the teacher suspects that the experiment was not done properly, and the student created the numbers manually. Why would the teacher have such suspicion? The options are: the variance is much less than the mean, unlike what is expected for a Poisson distribution. The standard deviation is much less than the variance as expected for a Poisson distribution, and the median is less than the mean, unlike what is expected for a Poisson distribution, and the median is greater than the mean as expected for a Poisson distribution. First D will be cancelled, because if this is expected, why would teacher suspect it? Okay, so D will be cancelled. Okay, now calculate all variance, mean, standard deviation and median of the this given distribution, and then we can draw the conclusion. So let's calculate first. So this is the counts we are given. So mean, this is the mean. We calculate the 113. This is the formula for mean. You know that, you know all. And this is the mean, and the variance we calculate is 6,000. This is much less than 134. So option A is right. Okay, so now go for the second option, checking all the other options. The variance, now the standard deviation is standard deviation is sigma. So this is 77. This is not very much less. They say that they're much less than the variance is not. Which is expected for distribution. So which is expected, teacher will not suspect about it from this. Now the median is 160, which is greater than the mean. So it is expected for Poisson distribution. The answer should be the variance, because as the standard deviation is much less than the variance, which is expected. So teacher will not suspect because it is expected, but which is not expected there, the variance is much less than mean, which is unexpected for Poisson distribution. So teacher will see that, and then teacher will suspect, no, there is some mistake there. So option should be option A. Question 19. Unpolarized light of intensity 200 watt per meter square is incident on the set of two perfect polarizer arranged one behind the other. The first polarizer has its transmission axis at 55 degree with respect to the vertical, and the second polarizer has its transmission axis at plus 100 degree with respect to the vertical. What is the intensity of the transmitted light? Okay. So first, unpolarized light of 200 watt per meter square is a first polarizer which is at 55 degree, which will immediately reduce the intensity. It means it is the polarized light when incident on the unpolarized light when incident on polarizer, it will divide the component actually I0 by 2. It will get polarized, so you will get the polarization of I0 by 2 intensity. And then this second polarizer, which is at 100 minus 55, this is 45 degree angle with the first polarizer. That means, so again this will decrease the intensity, which is the formula this by this I0 by 2 cos square theta. That means theta here is 100 degree minus 55, that is I0 by 4. Okay, so the answer will be 50 watt per meter square. The ionization potential of the hydrogen atom is this, given by this. If the mass of the proton and the mass of the electron is that, and the mass of the d nucleus is that, the ionization potential for d atom. This is the question. Actually, you can see the option here, which is very tricky. Actually, it requires you just calculate the Rydberg constant very carefully, and consider the mass of the atom, which will be reduced mass. Actually, you need to calculate that. This is the problem based on Rydberg constant and the reduced mass. So just this is the reduced mass for d atom, the reduced mass for the hydrogen atom. You just calculate this, put the value, all of the value above, and we will end up with the answer this. Consider the spaceship S of length L is moving relativistically in the x direction with a speed Vx relative to the inertial reference frame F as shown in the figure. In S, a light bulb is placed at the left end and the detector is placed at the right end point. What is the time taken for light to travel from A to B? You just need to at first differentiate S and S dash frame. That means the frame which is moving with Vx is S dash and the frame which is observing reference frame is F is S. Now we are writing the coordinates. Writing the coordinates in F frame, we get this. Okay, so this is the del T, but the in the reference frame, this is the time lapse between the measurement. So the observer in F frame will receive this signal or light beam at T2 plus del T. That means this, and T2 dash is actually T2 dash is here is L by C. This is the result. Just calculate this, you will get this. A beam of neutrons is incident normally on a fixed sheet of cadmium. The mass density of cadmium is rho, 8.6 gram per semi-cube. The absorption cross section of neutrons on cadmium nuclei is 2.5 into 10 to the power minus 20 centimeter square. But I think there is a little mistake here. I think the for the option A, there should be 10 to the power minus 22 order. Okay. The atomic weight of the cadmium is known to be 112.40 gram per mole, and you take n is equal to 6.02 10 to the power 3. At what depth the intensity of the beam reduced by a factor 1 by E? This is the question. So intensity through the thick sheet of cadmium, this is the formula. I is equal to I0 I naught e to the power sigma nx. Sigma is a cross section, n is the number of atoms present in this cadmium, and x is the thickness. So it was we calculate the number of atoms, that is rho into n by a is the mass number. Now calculate this, and I by I0 is given by 1 by E. You will get the answer x is equal to 9 micrometer. A electron is confined in two-dimensional square box in the ground state. Okay, the length of the side of this square is unknown, but it is seen that electron jumps to the first exchange state by absorbing electromagnetic radiation of wavelength 4040 nanometer. What is the length of one side of the square? Okay, so the energy for two-dimensional square box is this: n square x plus 1 ny square pi square h cut square by 2ma square. For ground state U11, that is this, and one excited state 12 is this. And now there is the absorption of electromagnetic radiation, which is this EC by lambda. By solving this, you will get 1.19 nanometer. Sorry, so that's this nanometer. Now question number 25. This is easy. The answer is 6. Now we come to the section C. You are given a matrix. You need to find out the value, determinant e to the power m, exponential of the matrix. Remember the formula: determinant of exponents of matrix is equal to e to the power trace of a. If the m is diagonal, if you diagonalize the matrix, this will be the formula. If you cannot diagonalize the matrix, it's also this formula it will work out. So you will get e to the power 0, which is equal to 1. Question number 2. This is the question. you are given a function, and then which is function of lambda, and which can be expanded as lambda is equal to 0, written by this form. f2, you need to calculate the value of f2. Now f2 is, if from Taylor expansion we know that f double dash 0 of 2, this is the f2. Now it is pretty much simple, just calculate, putting lambda equal to 0, you get the value of this root over pi by 2, root over pi by 2, and then this is f2 is equal to root over pi by 4. The horizontal constant force F is applied on a uniform disk placed on a horizontal surface. The mass of the disk is m, and the radius of the The point of application of F is at height h, which is less than 2r from the surface. The disk starts from rest at t is equal to 0 and the rolls without slipping. What is the speed of center of the disk at a time t? Okay, the torque applied on this disk is F into h. This is Fh, which is equal to I alpha. What is alpha? What is I? I is this at point, moment of inertia at this point. That means along the through the center is mr square by 2, and now at this point mr square, that means 3 by 2 mr square. This is the moment of inertia, and alpha is angular acceleration. Okay, so now we get this. So this is we get the angular acceleration. This is 2 by 3 fh mr square. Now the linear acceleration is this, a is equal to alpha, we get this. Now v is equal to u plus et, as it is transformed to rest, so u is 0, we get this v's expression. You can see this problem. This is very simple actually. You just need to calculate the Lagrangian, and then just need to derive the Hamiltonian. But the string is tight. It is tight throughout the motion. Mind that. So the Lagrangian, no, but this should be 0, because as you know the string is tight. There is no motion along this r direction. So this is the expression, and by applying these 2 and 3 formula, we will end up with this result. Okay, you can see the Lagrangian and the Hamiltonian. It's pretty much easy. Now you can see this operator which is operating on this